So Brett Young with Team Hack My Treehouse. We have a video, and then we'll do a little video, a little screen share. So. Is that working for everybody?
Yes.
Here we go.
The purpose of our project was to engage kids with a tech-enabled construction process that used off-site construction techniques and building as a product concept. The goal was a prefabricated assembly that could potentially be designed and assembled by kids, with or without parents.
Hello, Terran dwellers. My name is Tim Lindfeld. I designed the treehouse bracket for those of you who want to live elevated.
A separate group defined the core treehouse structure.
Hi, my name is Jake Olson, and I work with Eric Long on this treehouse hack to design beams, decks, girders, handrails, etc. Basically, two components. Number one was coming up with a prefab design system, which was 2x4s cross-drilled with these carriage bolts, and then number two was doing design calcs and providing constraints and limits on how these members can be assembled to form treehouses.
On the software side, the core objective was to be able to automatically configure a treehouse in an easy-to-use software environment.
I wrote the core deck and beam code, and that involved object orienting a 2x4 and then doing a lot of trigonometry, which
the team was aligned with two types of goals: core objectives, which were requirements and necessary for the project completion, and flex objectives, which are elective complexities. You never know who will be on your team at a hackathon, so flex objectives allowed our team to leverage the talents of other hack participants. The use of augmented reality and reality capture became our earliest and most complex flex objective because it led to a sequence of other flexes.
Our initial ambition with augmented reality was just to see if we could use a mobile device to determine tree trunk diameter and spacing. I'd used some augmented reality before, but never to do something like this, so I wasn't even sure if it was technically possible. By the end of the first day, we had essentially completed that task, and then we had 2 weeks to figure out how we could take augmented reality further to make this a better experience. So we had point clouds generated from that augmented reality tool, and so the first thought was, can we take these point clouds and send them back to the desktop as either E57 or XYZ file types? Done. So what was next? Well, what about actually showing the treehouse in augmented reality on your mobile device? Cool. So what the final task was then to make a fully functional AR app on iOS and Android to show and design a treehouse, and we were able to do that by the end of the 2 weeks.
Algorithms process the data to automatically identify tree trunks.
Hi everybody, this is Troy. I'm an architect living in Seattle. During the hackathon, I took charge of representing a real tree from anywhere like your backyard into the digital environment. So from the point cloud data we scan from the environment, the algorithm will select the points based on the desired level of your treehouse. and fit a circle on them, and then a cylinder could be formed to represent the tree. After that, the treehouse platform could be built.
The addition of reality capture data created new flex objectives, including the use of both Matterport and LiDAR scans as inputs for tree identification.
Because our data set got bigger, we needed a way to process the data so that we could do something meaningful with it.
The more trees you have to build your treehouse, say for instance, a forest, the more options you get to lay out your design. So we use a mathematical algorithm called the lone A to triangulate the trees in an efficient and beautiful manner.
As with most projects, some of our flex objectives were client-driven.
I told my dad I need a zip line for my treehouse.
Hello everyone, my name is Justin Miller. I'm a designer with Payette Architects in Boston. For the Treehouse Hack, I designed the Treehouse Hackers logo as well as the Treeple app logo. I also made a full visual prototype of the UI for the Treeple app in Figma, which was then interpolated into the working app. And I also made some other graphic goodies that hopefully you'll see.
We also made a website where we capture our planning, links to source code and executable files, lessons learned, and all media.
Hey, can everyone hear me?
Yes.
So part of our objective was to teach, get kids to like construction and to, engage with the built environment. In a study in 2009, only 1% of people in high school considered construction to be a viable profession. And that's despite people liking Minecraft, they like Fortnite, they like Lego, and they like all this, all these things. The difference with those is that those are a product, and construction is kind of a free-formed, build anything you want. And so our objective was to create a product of a treehouse. And so we narrowly defined it, and we went off and did it. And a product is different from a service because it encapsulates the entire kind of workflow of using AR, capturing the trees, modifying it, and then going off and fabbing it. So this is our treehouse. There's another one that was built today in Minneapolis, and hopefully there will be a bunch more. And I'm open to any questions. And